Assalamu alaikum. Today we'll talk about experiment 8, which is about IC and logic gate, which is a new part of the course. Basically, we're gonna talk about the digital circuit. This is our outline for today's experiment. First, we're gonna state the objective, what we learn after finishing this experiment. Then we'll talk a little bit about IC chip, and then we're gonna introduce to you the basic logic gate that is commonly used to build a digital circuit. And after that, we're gonna show you the data sheet for IC, what we mean by that data sheet and how to read it. And after that, we're gonna see how to connect the logic gate and IC in the breadboard. So our objective after finishing this experiment, we need to be familiar with the IC chip. So whenever you heard about IC, you need to know what we mean by that and how to deal with it, how to use it in the circuit or in the breadboard. Then we're gonna learn the basic logic gate, how the truth table for it, and how to implement it. And after that, we're gonna learn how to read the data sheet for IC, and most importantly, how to connect IC in the breadboard with switches and LED to build a complete digital circuit. So first of all, IC or integrated circuit, it means that a complete circuit that constructed in a small scale. So basically just a circuit that consists of electrical component like resistor, transistor. Most of the time they use transistor, sometimes they use a diode, other element to do some purpose or to implement it to do some certain task. So previously we saw the individual component of circuit like resistor, diode, capacitor, and for each circuit it has some purpose, and we can instead of building it by ourselves, there is some manufacturer build it in small scale and implement it inside this circuit or this chip in order to perform the desired task. So this is how it looks like. You can see that it has like multiple pins, so not like the resistor like have two wires. In here we have like multiple pins depending on the circuit used. Our today experiment, it has like 14 pins, 7 here and 7 in the right, and you can notice that you need to know the direction of the IC in order to know how to connect it. So obviously you can see this notch, we call it notch, الفتحة هذه اللي فوق, we consider it as a notation to indicate where I can place my IC in order to connect it right. We're gonna use this IC to build a digital circuit. So whenever we say digital circuit, it means that it takes input and it gives output, and this input it's only 0 and 5 volt, and the output we're gonna result on 0, 5. It can take multiple input. Most of the time they give one output, but it could give more than one output. What I'm more concerned with is whenever we say 0 or low, it means that I'm providing 0 volt. Whenever we say high or 1, it means that I'm providing to the input as 5 volt or the output 5 volt. So all the electric component gonna give me 0 volt or 5 volt. So I don't care about how much voltage go inside the circuit. I only concern about is there a voltage or not. So this is what we mean by 0 and 1. So the first basic logic gate that we have is NOT gate. So what we mean by NOT, it's kind of circuit that if you give it 0, it's gonna give you the inverse. So if the input A 0, the output is gonna be 1, and if the input is 1, and the output should be 0. To state all the possible situation for the gate, you need to build truth table. We call this truth table to make sure that what happened for each input. For the inverter or NOT gate, from its name, it's gonna take the opposite of the input. So whatever you supply, it's gonna take the opposite value. If you supply 0, the output is gonna be 1. So this is one important information about any logic gate. So logic gates consist of like 3 parts. The first part is the symbol. So this is the symbol for NOT gate. It's triangle with small circle. So this is important, the small circle. And you need to indicate how many input, how many output. For the NOT is only having 1 input and 1 output. And truth table to build to state all the possible situation. So the input either could be 0 or 1, and you need to study what happened for that input based on the circuit that you have. This is the second information that you need to know whenever you have logic gate. The third information is you need to know is the Boolean formula, the equation that I need to write it down to represent that I am having NOT operation. So from now on, this is consider our basic operation that we're gonna use to build the logic circuit or digital circuit, and to study what happened for the input and what gives us in the output. So today we're gonna introduce the basic, and after that we're gonna build a complete circuit, in the next experiment, in order to understand how to deal with this logic gate. So the output will be 1 if the input is 0. So this is one information that you can see to know what we mean by NOT. The second logic gate we have is AND. What do you mean by AND? And it takes 2 input or sometimes more and give us 1 output. So this is the symbol for it. It's like letter D, and you need to supply it with 2 input at least. So it does not work with 1 odd input. You need to supply it with 2 input, A, B. So whatever get inside the logic gate is the input, and whatever get out is the output. Okay, now I will build the truth table and study what happened for each input situation. So either we have both of them 0, or we have the second one is 1, or we have the first one is 1, or we have both of them 1 at the same time. So this is the all possible cases that we have for the input, and we want to study when the output gonna give me 1. And for AND, it should give us 1 only for input A, and B should be 1. This is why we call it AND, because it gives me only 1 if A and B is 1. So if the output will be 1 if only both of the input are 1. Or I can say A and B should be 1 in order to have 1. The other situation gonna be 0. And how to represent it in Boolean formula? We're gonna represent it as multiplication, but we don't call this multiplication. We call it A and B. So whenever you see A multiplied by B, we call it in logic circuit A and B. So this is the second basic logic gate. The third logic gate we have is OR. It's the opposite of AND in the way of dealing with the input. So again, takes 2 input, at least 2 input. Does not work with less than 2 input. In order to have 1 at the output, you need to supply 1 of the input. 1 is enough to have 1 at the output. So we're gonna study all the situation for the input, either 0 0 0 1 1 0 or both 1. For OR gate, you're gonna have 1 at the output if you have 1 input in is 1. So either A or B is 1, or is enough to give me the output 1. If both of them are 1, so this is more than I need, but you give me at least 1. So the result or the output is gonna be 1. So this is like the truth table for OR. So whenever you saw that the output ones, whenever you have 1 at least, it means that you are using OR logic gate. And how to represent it in Boolean formula? We're gonna represent it as summation. Again, we don't call this summation because we have here different operation. We don't have like algebraic operation. We don't have number to add. We have logic to understand. So either A or B is 1 or enough to have the output is 1. So what do you mean by it does not applicable to apply algebraic operation? So in algebraic operation, you know that 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0. This is now is okay, but what happened for the last situation? 1 plus 1, if you do it algebraically, the result will be 2. But since we don't have numbers in a logic circuit, I have only 0 1s. That's why we don't do algebraic operation. We do logic operation, and the summation is close to the OR operation. Or what you mean by OR? If one of the input is 1, then the output is 1. I don't care about the other. If one of the input is 1, it's enough for me to say that the output is 1. And this is the symbol for it. So whenever you saw this symbol, you mean we know that this is OR. So this is the 3 basic logic gates that you need to know, and you have to memorize it, and you know at least the Boolean formula, the truth table for each one of them, and the symbol. So whenever you saw this symbol, you need to know what does it do in the output. Okay, now let's go to the connection in practice, how to do the connections. So as I told you, this kind of logic gate is built inside IC. It's already for manufacture inside a small chip, and this is small chip we need to know how to place it in the breadboard. So this is the breadboard. First of all, we have the power lines, when you're gonna supply 5-volt and the ground, how to connect the 5-volt and ground. You're gonna supply it from this 2 line. This we call it power line. So this the whole line we're gonna consider as 5-volt, and the negative line consider as ground. Now if you bring the IC, this is how it look like. Once you place it, don't place it like here. So this is wrong way of connecting the IC, because as you can see that we know that for each column here to represent 1 node. Once you do that, you connect this leg of the IC to the this leg, and this is not this is prohibited in circuit in general. So as we learn at the beginning, if you try to connect any kind of element, don't connect both ends at the same node. فلا تشبك طرفين نفس الجهاز طرفين في نود واحدة أو عمود واحد. فإذا جيت تشبك الاي سي you need to bring it in between, in the middle, في الخط الفاصل هذا. بما أنه المساحة هذه مفصولة عن هذه، فكل رجل من الاي سي حتاخد عمود. So it's gonna look like this, and this is the notch that we're gonna indicate where we start the numbering the IC's leg. فلازم تعرف من فين تبدأ ترقيم الاي سي على حسب القطعة، وهذا اللي يحدد لي من فين أبدأ الترقيم. فإذا شفت هذا يسارها غالبا يكون 1. This is 1 2 3 4 5 7, then you're gonna go like this 8 9 10 until 14. So when you place it like this, each leg will take the whole node. So this leg will take this node, this leg will take this node, and so on. And similarly for the above part of the other part of the IC. So connect it like this, don't connect it like this. This way of connection is wrong. Now let's talk about the input, what kind of input that we have in circuit to represent the operation. We're gonna have switch to supply 5 volt or supply 0 volt. So it have like one movable part. If you move it to high or 1, it means you supply it, you make the input as high or 1 or 5 volt. If you make it in the low, you make the input 0 or supplying 0 volt. This is what we saw in the table. So in the table we saw that we have to study what happened for the output for each possible input operation. So you have either 0 or 1 for each switch that we have. So maybe you're gonna have multiple switch, and you have to study for all the situation for all the switches. So the switches you're gonna connect, you're gonna switch it to high and 0, and you're gonna study what happened in the output. So in the output we're gonna represent it as LED. لمبة إذا اشتغلت معناها on، إذا انطفت معناها off or 0 or 1. low 0 إذا كانت مطفية اللمبة تقريبا شكلها زي كذا، we call it LED. and high it's gonna have it's gonna turn on, and it represents that you have 1 at the output. So you're gonna change the input each time and study what happened for the output. So let's try to connect and see what happened for the NOT gate. So this is the data sheet for NOT gate, and this is the IC inside. This is what you see inside the IC. You didn't need to memorize this. Once you try to connect, you're gonna provide this connection diagram. So you can see that inside the IC I'm not having 1 gate, I'm having like 6, 1 here, 2, 3, 4, 5, 6, and they are numbered in this way. Okay, where is the input, where is the output? The input for the NOT gate, you have 1 and its output is 2. This is one NOT gate. The other one, the input for it is 3, the output is 4, and the third one is the input for it 5, and the output 6, and so on for the other. So whenever you use an input, you need to use the corresponding output. فإذا جيت تستخدم NOT gate مثلا تستخدم هذه، فلازم تستخدم 1 2. لا تستخدم 1 من هذه وتشبكها في الجهة الثانية 12، إن هذا مفصول عن هذا. واستخدمت 1 لازم تستخدم 2 اللي مربوط معه. وهذه طريقة تشبيك داخل الاي سي. هذا اللي يظهر لك داخل الاي سي نقول عليه داتا شيت. What you mean by data sheet? What the pins connection or what the pins number. كل رقم يمثل لي فتحة للنوت جيت، فهو input ولا output، فلازم أشوف هذه على أساس أعرف فين الانبوت فين الاوتبوت. And this is the notch, so you can see that the notch, the left part of it is 1, and you can start counting like this. And this is the power lines. VCC, it means that this is you connected to 5 volt, and ground, this is you're gonna connect it to negative or the ground. And this is the typical connection of the NOT gate. So this is the NOT. For example, you choose the first one. So you're gonna connect the input in 1, and the output you're gonna connect it in 2. And the 5 volt you're gonna connect it 14, and the negative or the ground you're gonna connect it in 7. So this is the typical connection of NOT gate by the IC. So let's do this in practice, and to understand how to connect it, connect the IC in the lab. So in the lab you have this breadboard. You're gonna bring the IC, and of course you need to know the number for the IC, because each IC has some number, and the number indicates what's the type of the IC is built for. So if you saw 7404, it means that this is not logic gate. 7404 هذا not. تيجي تحطه، طبعا تحطه في المكان اللي يكون مفصول بخط بين مساحتين، المساحة اللي فوق مفصولة عن اللي تحت، أجي أشبك الأي سي في المساحة هذه، ولازم تحدد فين الناتش تبعك. So this is the notch, so you're gonna start counting from here 1 2 3 7 and so on. So this is the connection diagram. I'm gonna follow it in order to do my connection right. So let's start to connect this 1 and 2 in order to see how to connect it. So first of all, you're gonna connect the positive. So this is the whole line for the positive 5 volt. You're gonna place it anyway since this is the whole line is connected. The negative, we're gonna bring wire connected to the negative line or the ground, since 7 is connected to the ground, and this is 14 connected to 5 volt. Now let's bring input. What's the input in our case is switch. So this is the switch. I'm gonna connect it in the input. What's the input for this first one is 1. Now what about the output? So we have only one input, and now I want to connect the output. I'm gonna bring LED and bring wire from 2 from the IC. So this is 2 from the IC. I'm gonna connect it to the output LED. Now my circuit is complete. I want to study what happened for the LED if I make the switch 1 and make the switch 0. So I bring the table and try to study what happened for each situation for the switch. So I make the switch 0, then I need to see what happened for the lamp. So whenever you make it 0, the lamp you're gonna see, or the LED, you're gonna be high 1, and this is obviously what we mean by not. So whenever you supply it, it's gonna give you the opposite. Now let's make the switch 1. Make it 1. The LED we're gonna switch to low or 0. So this is the output. So this is what you're gonna do in practice. Actually, you're gonna bring IC, you look for the number, and you have to know how to connect it, and you have to look for the connection diagram in order to know where the input, output, and the ground and the VCC or the 5 volt. Whenever you connect, try to build a table, verify what you know about not. So we verify what we know, since whatever I supply it give me the opposite. Now let's do the same thing but for AND. So this is the data sheet for AND. So it's somehow similar to NOT, but you can see here I'm having here 4 AND logic gate. Since AND here it takes 2 inputs, so 1, 2 consider as the input port, and 3 you're gonna consider the output for this AND. For the second AND, the input for 5, the output is 6. So whenever you try to connect, make sure that you choose the corresponding port, input and output I mean. And this is the number, you're gonna see it outside the IC in order to say that this is AND. So whenever you see 7408, this should be AND. And this is how to connect it in practice. Let's try to do it in the breadboard to see how to do it in practice. So again, bring the breadboard, the IC, gonna place it in between. Notice the notch here in order to know the numbers. So this is the notch, the 1 should be in the left, so this is 1 2 3 7 and so on. Then bring the data sheet in order to know how to connect. First of all, start to connect the VCC to 5 volt. So bring wire to 5 volt. Then the ground, GND to the ground. So this is 7, I connected to the ground. This is 14 connected to 5. Then I'm gonna bring the input. How many input we have? 2 inputs. So we're gonna bring 2 switches. The first switch I'm gonna connect it. Let's say that I choose 1. So I'm gonna connect the first switch in 1. The second switch I'm gonna connect it in 2. Since I choose 1, 2, so don't choose 11, don't choose 8, although they are output. You need to choose the corresponding output for your input. So this is the output 3. So 3, you're gonna connect it to the output. Again, doesn't matter where you place the wires, where the order, as long they are in the same column. فمهما حطيتها فوق تحت هنا، أهم شي يكون على واحد. يعني حتى لو حطيتها هنا، بس حطيتها هنا كرسم ما حتوضح معاكم. Okay. Now I complete my connection. This is input, and this is the output connected to the LED. Now I want to study what happened for what's the truth table, and want to verify it. So you know, AND gonna only give me 1 if both of the input is 1. Let's see this is what happened or not. So make the first switch 0, the second one 0, and see what happened. If you do that in the lab, the output or the LED gonna be 0. That's gonna be off. فما يعطيني لما ما تشتغل. Okay, let's make the first one 1 and the second one 0. خلينا الثاني 0 ونشوف. سويت كذا LED تلاحظ انها مطفية برضه مطفية. اوكي، نجرب الحالة الثالثة. نخلي هذا 0 والسويتش الثاني نخليه 1 ونشوف ايش يصير لللمبة. Again, you're gonna see that it is 0 since this is not what we expect for AND. And the last situation, if I make both of the switches 1, so this is 1 high. In this case, the LED you're gonna notice it's gonna be turned on, so it's gonna be high 1, and this is the only case that you have 1 for AND logic gate. So we verify what we know about AND. Now let's do the same thing for OR. So this is the symbol for OR, and this is the number IC number in for OR 7432, and have the same data sheet of AND. So it has 4 OR gate, and it's numbered like AND, 1 2 for the input and 3 for the output for the first one, and so on for the other. So let's connect it. Bring the IC in between. Notice the notch. Number the IC's leg in order to know where you're gonna connect your positive and ground and input and output. So to make sure that you're doing right, bring the data sheet. So 14 should be connected to 5, and 7 should be connected to ground or GND, the negative. Now I want to connect the input. So in this case I don't want to use this, I want to use the second one. So how to connect the second one? So I bring the first switch, connect it to 4. So this is 4. Okay, what's about second input? Second input should be connected to 5. Now I choose 4 5 for my input. Okay, what about the output? Where am I gonna connect it? Obviously I'm gonna choose 6. Since I already choose 4 5, I'm gonna choose 6. So it doesn't go in this way. So you can choose whatever of the OR gates that you want. مو لازم يعني تمشي بالطريقة هذه. يعني OR لازم تختار 4 5، AND لازم تختار 1 2. عندك 4 OR gate، عندك 4 AND، فاستخدم اللي تبغاه. ممكن تستخدم 10 9 كإنبوت و8 output، شيء راجع لك. بس هنا هالمرة عشان أغير. So the output for this should be 6. You connect it to the LED. Now I finish from the connection. I want to study what happened for the output for all the situation for the input. So let's start off making the first switch 0 and the second one 0, and see what happened for the LED. If you do that in the lab, the LED will gonna be 0. If you want make one is 1, if you make the first one is 1 and the second one is 0, you're gonna see in the lab the LED will gonna be on or high or 1. So this is what you're gonna see. Okay, let's make the first one 0 and the first switch 0 and the second switch is 1. What you expect from this operation? the LED again gonna be 1. So you somehow guarantee that this is OR gate. Okay, let's see what happened for the last situation. If you make this one and this one, this is what you get in the lab, and obviously this is the truth table for OR. So if you give one switch is on, it's enough for you to have 1 as the output. So this is the basic operation and connection of IC in breadboard for the NOT and OR. Try to understand how to connect in the breadboard in order to make sure that you know how to connect a complete digital circuit. So now we only use one logic gate each time. Next time we're gonna use multiple logic gate in order to build a complete logic circuit.